graph series, and the problem that we are going to solve today, that is building rows. So pipeline has n cities and m roads between them. The goal is to construct new roads so that there is a route between any two cities. So you have to find out the minimum number of roads required and also determine which road should be built. So let's uh, take an example to understand this. So you have four cities and two roads. The roads are between one and two and three and four. So you have city one, you have city two, and there's a road between them. You have city three, you have city four, and you have a road between them. So you can notice that there is no road between one and four, two and four, one and three, and one and four, right? Because one and two are in the different component, and three and four are in the different component. So there is no root. So there is no root between them. So you have to just find out the non-connected components. No, you just have to find out the non-connected components, connected components, and you have to find out the head of each component, and you have to just connect their heads, right? So in this case, there is one component, the head should be one and two, either of them, three and four, either of them. So you can connect one and three, you can connect two and three, you can connect one and four, you can connect two, right? One and four, one, three, and two, three, and one, four, and two, four, right? So the non-connected components are two. So to connect them, the required k minus 1 edges. So any one of them can be answered, right? Any one of them can be answered. So the answer can be 1 and 1, 3, 2, 3, 1, 4, and 2, 3. In this case, they print 2 and 3, right? Perfect. So how could you find the non-connected component? You can just apply BFF, or you can just apply BFF or DFS traversal. In previous video, I taught you BFF, so you can do it by your own. In this video, I will teach you DFS, right? So the aim of this series is not just solving the question. The aim is to learn the different concepts. So let's learn how DFS would work, right? So you have cities like that, or I can say that graph, it is an undirected graph. So let's make the adjacency list. So adjacency list. So adjacency list would be 2 and 4, 2, 3, and 4. 2, there is a edge between 1 and 2, 2 and 1, then 3 and 4, and 4 and 3. Right. So this is the adjacency list. So uh, what you could do that you travel for all the cities, travels for all the cities 1 to n, and you have to you have to traverse in that, right? So for all the edges from 1 to all the edges, you have to travel all of them and mark all of them visited. So what you could do that there is only one edge between 1 and 2, so let's make the visited array. Visited array. Yes, this is visited array. 1, 2, 3, 4, and initially they are all zeros. So for 1, you mark it as visited, and you push it into our answer. That it is the head of the first component, and then you travel all of its adjacent node, right? If there is something 5, 4, then you can also travel all of its adjacent node, right? So the adjacent node of 1 is 2, 5, 4, and you have to travel all of its adjacent node, and you just mark all of them visited, right? So how could you do that? You can use a stack, or you can use recursion. I use recursion. So you call DFS on that node and mark it visited. And for all adjacent node of that node, you have to call DFS. You have to call DFS of that adjacent node, right? Now, now you can see that you mark it as visited. Now for 2, it is already visited. Now you for 3, it is not visited. So there is another component that is present, that is 3. So you push it into your answer and mark it visited and call DFS on that node. And you just call DFS on that node, and you just mark 4 also visited, because this is the adjacent node of 3. Now you could find that there are two components, that is answer dot size gives you component size of the component, and you required k minus 1 edges. Suppose k is the size and k minus 1 edges, and you have to print 1 and 3, and the number of edges is 1. So this is the possible answer, right? So this is how you can apply DFS, right? Perfect. Now let's try to code it. Now let's code it. We have a number of cities and roads seen and m 4 type equals to 0, I less than m, I plus plus. Let's take the edges and x, y, seen x, y, make it zero based indexing, and let's create agency list. Twitter agency list. This is our agency list and agency list of x dot pushback y and agency list of y dot pushback x. This is for undirected graph, right? Now we have to do DFS int for int I equals to 0, I less than n, I plus plus. If not visited I, let's create visited array first. Int visited of size n comma 0, and we have to create answer also. Answer. Perfect. Now if it is not visited, then we have to put it into the answer pushback, because this is the head of the component. Then we call DFS on I, pass the agency list, and visited array. Perfect. Now we have to print our answer. Cout answer dot size. For k components, the number of edges required uh, are k minus 1, and we have to print answer dot size minus 1, I plus plus. Cout answer I plus 1, right? This is for one based indexing, and answer dot answer I plus 1 plus 1, right? This is our answer. Now let's make DFS function. Void DFS of, we pass node vector int ansif dj perfect, and pass visited array, pass it by reference, and if not visited that node, we have to make visited it, and for int and see as is a node of that node, we have to call DFS if not visited, as is a node, call DFS on that. As is a node comma asterisk comma visited array. Perfect. So this is our DFS function. Now I hope it's run correctly. Not visited. This is not visited. Yes, this gives us correct answer. That is the minimum number of road required one, and this is the cities between which we make a row, right? And right. So this is the code. The time complexity would be n plus m, and the space we are using n plus n. Right? For n is the number of edges, m is the number of roads. So we can say that n is the number of roads and m is the number of edges. Perfect. So thank you.